You are sitting in a room. Maybe you are in a long meeting, or maybe you are at your desk staring at a blank screen. Without you even consciously deciding to do it, your hand reaches out. You pick up a pen, you start to click it, over and over. Or maybe you start spinning a paperclip or peeling the paper label off a water bottle. For most of your life, you have probably been told that this is a bad habit, a sign that you aren't paying attention, a symptom of a wandering mind, or just a lack of discipline. But here's the strange part. Your brain doesn't see it that way. When you mindlessly fiddle with an object, you aren't losing your focus. You are actually trying to save it. To understand why your body does this, you have to look at how your brain manages energy. Your brain has limits. It can only process so much at once. Psychologists refer to this as cognitive load theory. Think of your attention like a delicate balancing act. Your brain thrives in a very specific zone of stimulation. Scientists call this arousal regulation. If your environment is too quiet or a task is completely uninteresting, your brain drops below its required baseline of stimulation. It starts to fall asleep at the wheel. But if your environment is too chaotic or a task is highly stressful, your brain shoots far above that baseline. It becomes overwhelmed by the noise. According to a neurological concept known as the Yerkes-Dodson law, optimal performance requires an optimal level of arousal. Not too much, not too little, just right. But the modern world rarely gives you that perfect balance. Most of the time, you are either bored out of your mind or completely stressed out. So your brain has to create the balance itself. When you pick up that pen or start bouncing your leg, you are subconsciously fine-tuning your brain's cognitive load. You are manually adjusting the dial on your own nervous system. It's not distraction, it's regulation. Let's look at what is actually happening inside your head when you are understimulated. Imagine you are listening to a monotonous presentation. Your prefrontal cortex, the part of your brain responsible for sustained attention and complex thought, is starved for input. To keep you locked into the present moment, this region of the brain requires a steady stream of a neurochemical called dopamine. When a task is boring, dopamine levels drop. Your attention inevitably starts to slip, but then your fingers start moving. You start spinning a ring or playing with the edge of your phone case. This repetitive tactile movement engages a process called sensory-motor integration. Because your fingertips are packed with nerve endings, touching and manipulating small objects feeds a direct stream of physical data into your nervous system. This subtle background movement triggers a microdose of dopamine in the prefrontal cortex. It wakes the brain up, it provides just enough sensory noise to keep your primary attention locked onto the boring presentation. You move your hands, the brain wakes up. Your focus remains. It is not a lack of focus, it is a fight for focus. But what happens if you don't fidget? What happens if you force yourself to sit perfectly still with your hands folded during a painfully dull task? Your brain doesn't just quietly accept the boredom, it rebels. If you don't give it stimulation, it will generate its own. It activates a powerful neural network called the default mode network. This is your brain's internal daydreaming circuit. When the default mode network takes over, you completely detach from reality. You start thinking about what to eat for dinner. You replay a conversation you had 3 years ago. You imagine hypothetical scenarios that will never happen. You check out entirely. Fidgeting is a defense mechanism against this. By occupying your peripheral motor pathways with a simple physical task, you are throwing a roadblock in front of the default mode network. You are giving the restless, wandering part of your brain a toy to play with, so the rest of your mind can stay anchored in the room. Your body solved this before you even noticed the problem. And this is where it changes, because you don't just fidget when you are bored, you also do it when you are overwhelmed. Think about being in a high-pressure situation. Maybe you are waiting in the lobby for a crucial job interview, or you are about to have a very difficult conversation with someone you care about. Your heart rate is up, your chest feels tight, your body is suddenly flooded with cortisol and adrenaline. Your ancient fight or flight system is preparing your body for physical survival. It is telling you to run or to fight, but you are just sitting in a chair in a waiting room. You have all this nervous, kinetic energy and absolutely nowhere to put it. In evolutionary biology, animals do something very specific when they are caught between two conflicting instincts. If a bird is threatened by a predator but doesn't know whether to attack or fly away, it might suddenly start preening its feathers. If a squirrel is startled, it might freeze and suddenly start grooming its face. They perform a completely irrelevant, repetitive action. Scientists call this a displacement activity. When you are intensely stressed and you start tearing a piece of paper into pieces or picking at your fingernails, your brain is doing the exact same thing. It is actively bleeding off the excess pressure. These repetitive micro behaviors act as a physical release valve for emotional spikes. Every time you click that pen, you are draining a tiny drop of adrenaline. Every time your foot bounces against the floor, you are physically lowering your cortisol levels. You are moving the anxiety out of your mind and pushing it into an object. You're not losing control. You're regulating it. Society has trained us to view the mind and the body as two completely separate things. We like to think of the brain as a master computer, trapped inside a skull, issuing commands. We think the mind gives the orders, and the body just blindly follows them. But your brain doesn't see it that way. In modern psychology, there is a fascinating field of study known as embodied cognition. It's the understanding that your physical body is actually an active part of your thinking process. You don't just think with the neurons in your head, you think with your hands. You process complex emotions with your posture. You solve difficult problems through physical movement. When you mindlessly interact with the physical world around you, you are offloading cognitive weight. You are using the objects in your environment as an extension of your own nervous system. You are outsourcing your emotional regulation to a paperclip, to a pen, to a rubber band. The object is no longer just a random piece of office supply. It becomes an external tool for internal balance. It's not a flaw, it's a feature. For decades, we have tried to force people to sit completely still. We tell children to stop squirming in their seats. We tell adults to stop tapping their feet in meetings. We have treated the human body as an inconvenience to the human mind. But science is finally catching up to what your body has known all along. Stillness is not always a sign of focus, and movement is not always a sign of distraction. So the next time you catch yourself spinning a ring on your finger, or peeling a label, or doodling abstract shapes in the margins of a notebook, don't try to force yourself to stop. Don't view it as a weakness or a lack of discipline. Recognize the behavior for what it actually is. It is a highly sophisticated subconscious strategy. Your nervous system is silently running complex diagnostics in the background. It is constantly monitoring your dopamine levels. It is actively checking your cortisol levels. And it is making rapid split-second physical adjustments to keep you safely balanced in a chaotic world. This isn't a reaction, it's a system. This isn't just a habit, it's intelligence in motion. Once you start seeing these hidden patterns in human behavior, you don't really stop. And if something this small and this automatic is this intelligent, what else is your brain doing that you've never noticed?